Section 3.4, Solving Non-Linear Systems Using Graphical Method. Definition of a system of linear equations in two variables. A system of non-linear equations is a collection of two or more equations in which at least one equation is not linear. A solution of a system of non-linear equations in two variables is an ordered pair or a set of ordered pairs that satisfies each equation in the system. So I repeat, a solution is an ordered pair or a set of ordered pairs that satisfies each equation in the system. So let's check the first example. Determine if the given points are solutions to the following systems. Since part A and part B are also solved in the PowerPoint, I'll explain only part C. We have the point -2, 4. Let's check if this point satisfies equation 1. So first, as a reminder, -2 represents x, 4 represents the y. So let's replace -2 in the equation. We're going to have -2 squared minus, instead of y, we're going to write 4 equals to 0. Is this true? Let's check. -2 squared, 4. Is 4 minus 4 equal to 0? Yes. 0 equals 0. Perfect. Now let's check for equation number 2. It's x plus y. So I'm going to write -2 plus 4. Is this equal to 2? -2 plus 4 is 2. 2 equals 2. True statement. That means yes, it is a solution. Let's continue with example number 2, part B. We have to find the solution of this system. To find the solution to the system, we have to find the points of intersection, the points where the graphs meet. So let's look at the graph and see where do the two graphs meet. We notice this is the first point where the graphs meet. The coordinates -1, 0. And the second point, it's right here. The coordinates for this point are 1, 0. After we write down the points, now we have to check to see if they satisfy both equations. So let's do that. I'm going to write down here. I copy the system so we can see the equations. So let's check for the first point. The first point we found was -1, 0. Where -1 represents the x and 0 represents the y. Let's replace the values in the first equation. So we get 0. Let's check if it's equal to, it says x squared. Then I'm going to have -1 squared minus 1. 0, is it equal to -1 squared is +1. So 0 equals 1 minus 1? Yes. 0 equals 0. That's true. Let's check for the second equation. So I have 0. Let's check if it's equal. The equation starts with negative, so I'm going to write the negative sign, and then it says x squared. Who's my x? My x is -1. So I'm going to write that in parentheses to the power of 2 plus 1. Let's check if 0 is equal to, the negative sign stays, it's not affected by the power of 2. And then the parentheses, we have -1 to the power of 2. That becomes +1. So now I have -1 plus 1, -1 plus 1. And that is equal to 0. So again, we got a true statement. Now let's check for the second point. Our second point was 1, 0. So this time 1 represents the x and 0 represents the y. 0, is it equal to 1 squared minus 1? Let's check. 1 squared stays 1. 1 minus 1 equals 0. Perfect. And now for the second equation, we have 0. Is it equal to negative? The negative is not affected by the power of 2, so it stays outside. 1 in parentheses to the power of 2 plus 1. Let me move my screen a little bit, like that. So now let's see. 0, is it equal to -1 plus 1? Yes. 0 equals 0. The solutions of the system are the points -1, 0 and 1, 0.